This lesson 40.A in the Saxon Advanced Math book is regarding the term argument. Now, I put up here the different definitions. If you take the time to read through the article here, there are some different definitions in respect to the word argument. The first thing that the book mentions is that argument has an English meaning to it as well. If I were to say you were in an argument with someone else, what you're really saying is I had a disagreement, a heated discussion with somebody else. That's the English definition of argument. In mathematics, the word argument has three different definitions that we're going to look at here, and we're going to center in on the third. The first one is the connection of statements or reasons. And I put up here, think geometric proofs. This is where you're saying, this is the argument you're placing forth. This one is much like this, the English version of an argument, because what it's saying is I am presenting the facts for my case, if you will, and that is the argument I'm referring to. The second is the polar form of complex numbers. I'm going to cover this quickly. If this is not review for you, if you don't remember what polar or what imaginary numbers or complex numbers are, this is going to be a little bit foreign. We will go over it later on in the curriculum. But remember, I write the normal method of writing a complex number is real plus imaginary. This would be the I would be after the imaginary portion, and the real numbers like 6 plus 3i would be real plus imaginary. That's in rectangular form or on the Cartesian plane. This is the other way to do it, which would be the real is your x, and your y value that you normally would have for y is your imaginary plane or imaginary axis. And the r is my radius. And so I would write it as r cosine plus I sine theta. If that is completely foreign to you, don't remember that, it's okay. We will cover it later on. But for right now, what we say is theta, the angle, or theta is the argument of this, and r is the modulus, or the radius is your modulus. That's the second method or the second definition of saying what an argument is. Now, this one here, like I said, if this is foreign to you, that's okay. We haven't covered it in this year's text, although it was covered just briefly last year. And then your final definition of an argument is when we're referring to functions. If I were to say the argument is what you're putting in to the function. So if I said I put x into my function and I get out of it the f of x, this would be, for instance, if I said y equals sine x, the argument that I'm putting in of the function, x is the argument that I'm putting in to the function y equals the sine of x. Or I could say f of x equals the sine of x, and it's still x is the argument that you're putting in. It's the variable that I'm substituting in for. So if I looked at this and said the f of x equals 2 cosine of parentheses x plus 1, this is a little confusing here just for a moment, but the x plus 1 is my argument. The mathematicians and different math books write it differently, but for our text and kind of an understood method of writing this would be that anytime I use the parentheses like this that encases my variable, I'm going to call that whole thing my argument. This is the function 2 cosine. The x plus 1 would be the argument for this. That's 40.A. That's the different definitions of the word argument. We are going to build on this with an argument, putting it into a function a little bit later. But for right now, if you just realize that's what an argument is, you'll be fine.